Hello everyone, thank you for watching. On behalf of Alice, I'd like to welcome you all to this video. In this presentation, I'm going to talk about development of small hydropower and utilization in the region. My presentation will take about 45 minutes and is divided into 6 sections. Section 1 is about our company. Second, our small hydropower development. Third, our newly developed small hydropower. I will show you product video. Fourth, suitable place and procedure for small hydropower. I will explain it using our existing power plant in Nimi City as an example. Fifth, maintenance and business feasibility assessment. The last, local cooperation and future tasks in Japan. So let me start from introducing our power plant in Nimi City. This is our power plant in Nimi City that's selling electricity since 2016, and this is the open type small hydropower. That power plant will be in Small Hydropower Guidebook publishing by MLIT. That was the first private business project in 2016. As I mentioned earlier, the power plant in Nimi City is an open type of small hydropower. But there are roughly two types of power plant that open vertical type and closed type. The closed type is difficult to prove and thus the open vertical type has problems such as shaft run out. The spiral turbine type requires a bypass channel and cannot be accommodated with a width of 1 meter. But our open type of water oil features has highly efficient and low shaft run out. Alice started its business in December 2001 as a group company of Tsubame Holdings, which is focused on LP gas business in Okayama Prefecture. In addition to such small hydropower, we also engaged in other environmental energy business, such as solar power. However, our business initially started stream system, and we conducted research and development with engineers to optimize the stream system. Now, I would like to talk a little bit about the stream system. The stream system is a device that has been introduced at the Japan Institute of Sports Science and is used for training swimmers. This photo is a special pool equipped with the device. The device is allowing water to flow evenly, visualize the waste of swimming form, and improving their swimming form. Former Japanese Olympic gold medalist Kosuke Kitajima also used it for training. Since the body will flow in the water, it causes buoyancy act in the water. It is effective for muscle training. This is the device. So, Alice started its business with such a stream system. Now I'd like to introduce the process leading up to the installation of the small hydropower plant that I explained earlier. Our history of micro hydropower begins with the production of the generator in 2006. Developed the original permanent magnet generator in 2006. In 2008, we installed a monument water well in an izakaya restaurant in Okayama City, and its hydropower was used to eliminate the electric board in the restaurant. 2009, we installed an open-type water turbine with a Pacific Consultant and an agricultural canal in Okayama City. That was a project of MIAC. It was before the Great East Japan earthquake, at a time when the national policy was to increase the number of nuclear power plants to about 100. It was a time when distributed energy was said to be strange at the time. But this project was reported various media and became a hot topic. Also, some local governments came to visit the project. After that, we installed a product in Go-no-Ka Canoe Park as a demonstration experiment of dust countermeasures by the Reconstruction Survey Design and the Environmental Policy Division of Miyoshi City, Hiroshima Prefecture. and the hydropower was used to a festival in the park. After the earthquake, a small hydropower was installed as a PR for the Headwaters Summit in Shinjo Village, Okayama Prefecture. The hydropower is used in the farmers' market in the village. We also conducted a demonstration experiment of propeller turbine at the fish farm in Kagamino Town, Okayama Prefecture, for about a year. I would like to talk a little about our propeller turbine at the demonstration experiment. This is a video of demonstration experiment of a fixed propeller type turbine that we conducted with the propeller manufacturer. This is a fixed propeller type turbine. In this way, dust got entangled with the shaft and forced to stop power generation. If this happens, maintenance will be required, and of course, the maintenance cost will increase. In particular, there are many places where there are shortage of labor to maintain and manage water in agricultural canals. And being able to maintain the water and canal management is an important factor when considering to install a water turbine. For this reason, open-type water turbines have been recommended, and our company has also advanced the original development of open-type water turbine. In 2016, I introduced at the beginning, we started operate power plant in Nimi City. In 2018 November, we have put into operation the Kuwatani LS power plant, Tsuyama City. It's a self-consumption model that utilizes discharge water from power plant. The power plant is supposed to charge small mobility with the power generated only by hydropower. In addition, the Nimi City model was targeted third-party evaluation by the Environmental Technology Verification (ETV) to visualize efficiency. The verification was supported by Okayama Prefectural Industrial Promotion Foundation, and we conducted fluid analysis open-type water turbine in collaboration with West Japan Fluid Engineering Laboratory, which has stream water technology, and Nagasaki University Graduate School, which has knowledge of small window power generation. In a model experiment, we analyzed the number, angle, and shape of hundreds of type of blades and optimized the blade shape and number of blades. Today's water vehicle has achieved this optimization. We have obtained trademarks, designs, and patents for this intellectual property all over the world. The adaptive area of water vehicle will be this red shaded area, but there are ranges where the head is 1 meter or more and the flow rate is 1 cubic meter or more as the most profitable can be secured. There are inline tubular turbine and fixed coupling turbines that can handle low flow rate and low head with high efficiency, which are common in Japan. However, those are hard to install in long term due to the problem of clogging with dust. A point where the head exceeds 50 meters has already been developed. Although there are many low flow and low head waterway, they have not yet been developed. Water vehicle is a water wheel that can handle the part. So now I'd like to show you our product video.
Water Weco. Efficient microelectric power generation is now possible even in low head and low water flow conditions. We at Water Weco have conducted research and development into installation in low head and low water flow conditions, even in cases that would previously have been considered impossible. In September 2017, with the support of Okayama Industrial Promotion Foundation, Water Weco announced the results of its joint research with West Japan Fluid Engineering Laboratory, which has top-level research facilities and fluid engineers, and with Nagasaki University, which has done research and development in fluid engineering and high-performance turbo machinery. The stages of research and development consist of fluid analysis, model experiments, output confirmation in field demonstrations, and product development. we have improved accuracy by testing before modeling using CFD, computational fluid dynamics. We currently produce two types of water wheel, one in which water flows in from the bottom of the water wheel, and another in which water flows in from the center. First, the open-type undershot water wheel. In February 2016, Ellis signed an agreement with Tsuyama City in the north of Okayama Prefecture to work with local residents to reduce environmental footprint through local production of mini hydroelectric energy for local consumption. One key feature of open-type undershot water wheels is that they can be installed in places where there is almost no head. The flaps on the trailing edge of the blades are angled in the direction of water flow, and blades that can maintain high output over a wide operating range are used. We announced our research results to the Japan Society of Mechanical Engineers at Saitama University in September 2017 and at the Mini Hydro Energy Seminar co-sponsored by Nagasaki University and Ellis at Tokyo Institute of Technology in the same month. The paper was published in the November 2018 issue of Clean Energy and in the April 2019 issue of Turbo Machine. Our intellectual property has been registered not only in Japan, but also in Europe, China, and Taiwan. During research, the maximum output efficiency ran over 40%, which was higher than the output efficiency of the conventional open-type fluid water wheel. Here are some videos of model experiments. Efficient water wheels scatter less water, as you can see comparing the videos. Second, the open-type breast-shot water wheel. We invented a new open-type breast-shot water wheel in 2021. This product has been tested and compared to an existing model at Takao Ellis Power Plant in Nimi City, which has been in operation since March 2016. This power plant has received a third-party evaluation by the Ministry of the Environment. In our research, when we made a same-scale model as the Nimi City power plant and measured the output efficiency, we found the same results as the assessment of the Ministry of the Environment. A key feature of the open-type breast-shot water wheel is that it's possible to install even in low head and low water flow conditions. In this type of water wheel, since the body force between the blades of the impeller is converted into angular momentum, concave blades that can effectively hold the mass of the fluid in the shape of the blades are used. When the water wheel is flooded, the quantity of excess water can significantly influence output efficiency. This is called stagnation, another element we tested. In the June 2019 issue of Clean Energy, we published the results of our comparative testing against the Takao Ellis power plant in Nimi City, focusing on stagnation. We also published the research results of our open-type breast-shot water wheel in the December 2019 issue of Clean Energy. Since then, in the January 2021 issue of Clean Energy, we published our patented technology, a unique mechanism that changes the water wheel layout according to flow rate fluctuation. This patented technology has made it possible to maintain stable output even in environments with fluctuating flow rates. In addition, on the 28th of May 2021, Japan Economics newspaper published an article, Plan to install 11 consecutive units in irrigation canals in Niigata Prefecture, referencing a project we developed. We install water wheels with this technology not only in Japan, but also internationally. Our intellectual property has been registered not only in Japan, but also in Europe, China, and Taiwan, etc., as in the case of the open-type undershot water wheel. Based on our research results, plotting the peripheral speed ratio on the x-axis and the output efficiency on the y-axis, the maximum output stands around 40%, even when there is stagnation, which is around 15% higher than the water wheel at the Takao-Ellis power plant in Nimi City. Furthermore, in this study, after finding that stagnation hinders the rotation of water wheels, we changed the structure of the water wheel at the Takao-Ellis power plant in Nimi City. At the third-party evaluation in 2019, its output efficiency was approximately 31%, but after our modifications, this improved to 47%, 1.5 times more efficient. When we applied this technology to our new product, WaterWeco, the output reached 54.8%. Here are videos of our model experiments. Efficient water wheels scatter less water, as seen before with open-type undershot water wheels. Now we'll explain the key features of WaterWeco, our new, highly efficient breast-shot water wheel. The first feature is a unique remote monitoring system. This system uses remote monitoring technology developed with Toyo Keiki, which has a long track record in the field for LP gas power generation. Of course, signals such as power status abnormalities are also sent to the remote monitoring center 24 hours a day, 365 days a year. The second feature is that civil engineering is not required. These are photos comparing before and after the installation of the Takao-Ellis power plant in Nimi City. The initial cost can be significantly reduced because the water wheel almost never needs civil engineering to be installed, as can be seen in the photos. The third feature is that it is easy to maintain. At Takao-Ellis power plant in Nimi City, we installed a screen to prevent entry of debris and cleaned it regularly, but for the newly developed WaterWeco, no such screen is required because the blades only touch the surface of the water flowing into the water wheel. Moreover, there is a forebay between the turbine and the headrest, into which debris such as branches and leaves flow, so there is no need for cleaning. For this reason, not only the initial cost, but also the maintenance cost can be significantly reduced. Also, when installing a water wheel, you can conserve the upstream migration of fish because the forebay works also as a fishway. You can also check the debris status from your smartphone through a surveillance camera. Furthermore, regarding the water wheel noise levels, the Nimi City water wheel measured 71 to 82 decibels within 100 meters downstream, according to the evaluation of a third-party organization. The reference value for mental and physical complaints is 92 decibels, which is 10 decibels higher than the level even 1 meter from the plant. In fact, there is a block of flats just 30 meters from the plant, but there have never been any complaints about noise. The fourth feature is our own unique generator. Since this generator is suitable for low torque and low rotation speed, it requires only a low speed increase ratio, has a long service life, and can extract 100 volts AC electricity if it is rotated at a constant rotation speed. This generator is used at the Kuadani-Ellis power station in Tsuyama City. This generator is a synchronous generator, which, unlike the induction generator, can be operated independently and thus can be used in emergencies. These are all the key features of WaterWeco. The world is now facing an unprecedented global warming crisis. To address this issue, it is necessary to make good use of local natural energy and build a sustainable society through decentralization of energy. Therefore, it is necessary to continuously implement policies that enhance the economic cycle, such as energy self-sufficiency, employment, and tax revenue in the region. According to research by the Kyoto University and Hitachi Kyoto University Lab, which are conducting research on independent communities, when the self-sufficiency rate of electricity from renewable energy is 95%, The economic circulation rate of the local community is 7.7 times greater than with the existing electricity supply. It is possible to play a part in building a sustainable society by effectively utilizing hydropower and not leaving flowing water untapped. In terms of CO2 emissions from sources such as Costa manufacturing, according to one study, hydroelectric power generation emits only 11 grams of CO2 per kilowatt hour, less than 1/3 than solar power generation. You can install WaterWeco even in low head and low water flow conditions, which have previously been impossible to install, and can make more effective use of untapped hydropower. You can also use it as a backup power source for emergencies. As an environmental energy company, we will provide an environmentally friendly energy system that works closely with the local people, and will take the initiative in realizing a local community where children who will lead the future can live with peace of mind.
Thank you for watching the video. I hope that was easy to understand and understand what challenges Japan is facing. Then how will Japan promote renewable energy in the future? The current national policy states we will strengthen cooperation with the ministries and agencies that has jurisdiction over the existing infrastructure and such as head races, and promote the installation of generator in head races, and aim to increase the amount of power generated. However, is there a market for such a small hydropower? This is a report summarizing the markets between Europe and Japan. According to this report, small water turbine has been popular in Europe for a long time, and there was a place where many water turbines were installed in Japan as well. According to the literature that investigated Uton turbines, there are many turbines in Japan. According to the literature of Mr. Kiyoshimada, the conventional turbine was a Uton turbine with a head of 1 meter and a flow rate 1 cubic meter or more. Some local governments had more than 3,000 such turbines. It is said that there are many places marked with red circles. Also, according to Japanese Association for Water Energy Recovery, the potential of small hydropower is said to be equivalent to that of 3 nuclear power plants. In the future, the market size will expand, and it is predicted that it will expand to 59.3 billion kilowatt hour in 2030. Now is the time to disseminate renewable energy that is ethical in the spirit of the SDGs, that is sustainable, environmental friendly, and has high regional economic effect. In Japan, the demand for decarbonization has increased in recent years, and fossil fuel-based thermal power plants have been shut down one after another. Due to the Fukushima nuclear accident, the nuclear power plant cannot be restarted. The nuclear power plant is also called a mansion without toilet and goes against the idea of SDGs. We plan to significantly increase renewable energy, but due to policy failures, solar and wind power, which are not baseload power sources, are increasing, and the supply of electricity during the day exceeds the demand. The use of heat for biomass has not been established, and it is said that it will be difficult to achieve the numerical target for 2030 without using 40% of the world wood market. Geothermal has great potential, but it takes time to get permit, and most of places do not proceed with negotiation with existing hot spring business associations for the use of geothermal heat. Therefore, there is an increasing need to use small hydropower that utilize the effective head of existing agricultural canals and wastewater from factories. So I'd like to talk about the concept, design, applications, procedures, construction, and maintenance for commercialization. First of all, whether there is a suitable place and whether the manager of land is willing to install hydropower are important factors. As I mentioned earlier, in the Renewable Energy Reserve Survey by the MIAC, Pacific Consultants and Okayama City from 2009 to 2010, which are conducted a demonstration experiment in the agricultural canal Nishigawa, in the center of the city. At the time, we interviewed by a lot of media and we were able to interact with a wide range of people, including local governments and researchers. At the time, the union that manages the agricultural canal in Takao, Nimi City, was interested in our project. And later in 2018, it became an opportunity to install our hydropower in Nimi City. Now let's talk about how to establish hydropower business. The LS power plant in Nimi City rents waterways. What is waterway renting? We rent a waterway, install a water well at our expense, and carry out a power generation business. The generated electricity is sold under the feed-in tariff system, and a part of the profit is returned as a rent. We also pay land rent and waterway usage fee to Land Improvement District. In the case of Nimi City, paper mills used to be active in the past. Therefore, we were able to share our thought, which to contribute to the environment by effectively utilize the power of discharged water with local people. This photo is a before installation of hydropower. This agricultural canal is a general low flow, low head irrigation canal with a flow rate of 0.809 cubic meter second and a head of 1.3 meter. It is an agricultural canal taken from A-class river and managed by No Building Water Association. So considering business profitability, the commercialized water turbine can be installed in a place with a head of 1 meter and a flow rate of 1 cubic meter or more. Once the location is decided, we will make drawings. To obtain the heat required for power generation, it is necessary to create high difference from the water gate to head. We install head race with gentler slope than canal, and make it so that when the head race reaches a certain height, water will fall from the head race. When you install the head race, you can get certain amount of power output even with a small amount of water. Basically, we will consider the most economical design that suits the situation while comparing the construction cost and the amount of power generated. The location in this photo will be the next location for the installation in Niigata, Japan. To obtain the heat required for power generation, it is necessary to have a place to convey the power of water to number of revolutions of the turbine. As a result of hydraulic calculation, the dust device is no longer needed, so the turbine layout will be changed according to the flow rate fluctuation. We need the most economical design for the installation location, comparing the construction cost and the amount of power generated. By the installing turbine in the position where there is no stagnation, the efficiency of the turbine can be increased and the load of the shaft can be reduced. Hydropower is a permanent business and requires verification from different perspectives. Not only potential energy, but also velocity energy is an important factor in the design. So we will perform design calculation corresponding to flow rate fluctuation. The design considers the overflow and design the head raised water level. As I said, to obtain the heat required for power generation, it is necessary to create high difference from the water gate to head. But the overflow should not sparkle water around the head race. Since the water turbine uses only the surface water, it basically does not become an obstacle and cause the water to overflow. Nevertheless, accurate water use calculation is required. In addition, consider the timing of water outage. It will take at least half a year from the concept, depending on the coordination with the related parties. The construction period is about 1 month. In addition, electrical equipment is required to link the power generation system. As an option, you can also install equipment that can be managed and monitored with a remote monitoring camera. In Japan, we use a system called Subordinate Power Generation Registration System that uses the water flowing in agricultural canal as it is for power generation. First, regarding the river law in Japan, when applying for a permit for river law, permission from the administrator is required to use river water, even if it does not consume river water like small hydropower. This is called permit to use water, which is called water right. For generation using agricultural canal is called subordinate power generation, which is power generation using water taken from other purpose. And the original use of water is called subordinate source. In this case, small hydropower require permit because it used water from different purpose than the original use of water. Due to the revision of River Act in 2013, a registration system was introduced for subordinate power generation that installs hydropower generation in agricultural canals. It is now possible to install by following the procedure according to the manual. As a result, the procedure has been simplified and facilitated, and the period for obtaining water rights has been significantly shortened. Currently, it is written as standard processing period of 1 month. However, to use this system when applying for a power plant in Nimi City, it took about half a year to wait for deregulation. At the time, deregulation was not processing, and there was various difficulties. A flow survey was required for 1 year because of the Water Act. Next is electricity consultation and feed-in tariff in Japan. If you want to sell generated electricity, you need to connect it to the transmission and distribution line of the electric power company. After discussing with the electric power company in advance whether there are many problems with the power quality and safety of this interconnected power generation facility, it is necessary to create a construction plan for 1 cubic meter second or more, but it is necessary to obtain permission for interconnection before creating it. Alternatively, you can use a virtual power plant, or if you don't have a power line, you can send power directly from the power plant to the community. According to the Road Act of Japan, if you intend to continue to use the road by installing any of the following structures, properties, or facility of the road, you must obtain the permission of the road administrator. It is written. Therefore, we need to get permission from the prefecture, which is the administrator of the road. However, the prefecture replied that the installation of the uncle bolt was not permitted. Why was it not permitted? As you can see from the photo, there is a road on the right side, and the prefecture managed this road and the waterway, and the repair is borne by the No Building Water Association. Let me talk a little about this situation at the time. For some reason, the No Building Water Association was paying for the repair of the national road that was the revetment of the irrigation canal. When the Water Association heard that, the prefecture replied as the installation of the Anchor bolt was not permitted. The Water Association told the city, "We, the union, paid for the repair of the road. But what is the point of not being able to hit the Anchor bolt in the irrigation canal, which is necessary to installing hydropower generation? If you say the road is national property, we will not repair the road anymore." The decision made by the prefecture after hearing the protest was the idea of changing the manager to the city from prefecture. When the manager became a city, Uncle Bolt be stuck at the discretion of the city. And since power generation business was promotion business of the city, the application permission was granted safely, and the plan for construction finally proceeded. In addition, noise control also required the utmost consideration for the neighborhood. Originally, there is water noise in headworks and torrent works, but there was no noise level that would be complained in the measurement after the installation. This is a monitoring center for small hydropower generation in Nimi City. If there is something wrong with the power conditioner, the center will be notified immediately. As a result, the status of installation location was monitored 24 hours a day, 365 days a year, and a rush system was set up just in case. And no need for expensive dust removal cost. In addition, electrical equipment is required to link power generation and grid. Also, equipment that can be managed and monitored by a remote monitoring camera is required. Of course, you can also install devices that can grasp the local situation more accurately as needed. With a closed-type micro-hydropower in agricultural canals, there is a problem that even fine dust such as grass and leaves can block the flow path, making it impossible to secure the planned amount of power generation. Therefore, Nimi City has adopted an open-type water turbine. This document is a water turbine that is recommended on the homepage of other prefectures in Japan, and it is easy to maintain because it is not easily clogged with the garbage. It is said that the open type easier to maintain and can be installed in the waterway. When installing a water turbine to torrent water, the utmost care must be taken to conserve the fish running up. Due to the heavy rains in West Japan in the summer of 2018, the revetment of Takahashi River, a first-class river that draw water from agricultural canals, broke down and became a disaster. However, although the water stopped at the power plant in Nimi City, no damage was found to the equipment. It is also equipped with a mechanism to raise the turbine to prevent over-rotation of the turbine, just in case. Even in the event of power outage, power is stored in the battery, and even if a dead animal is caught between the water well and the chest wall, the water well can be automatically raised. In terms of profitability, if we continue to operate for 20 years, the profitability has improved significantly compared to our conventional type due to the improvement in efficiency. In addition, if multiple units are installed in the same irrigation canal, the initial cost and the maintenance cost will be lower. So it is more profitable to install multiple units in one agricultural canal. Large-scale hydropower is excellent in terms of energy efficiency, but there are no more places where it can be installed, and high construction costs will be unrealistic. Since environmental and ecological conservation is an important point of view, it is expected that small hydropower will become widespread in the future. However, the output of small hydropower is low, and our conventional type was about 30%. In order to solve the problem, we were able to exceed 50% through development research of various problems. This is a data that summarizes the output of power plant installed in Nimi City. After calculating the output where it's shown as 4.25, we were able to get 47% of the data. By the way, where the numbers are falling, the water turbine was not in operation during the period of heavy rain. I will explain about stagnation later. By eliminating the stagnation, we were able to further improve efficiency. See this video. The left is a conventional type, and the right is the new type. The one on the right has almost no splashes, so you can see high efficiency. The power generation efficiency is visualized in the graph. Now I'd like to explain about stagnation. Please see this image. As shown in the image, the status where the water wheel is submerged in the water is called stagnation. Since the output efficiency will decrease if there is this stagnation, We have worked on this improvement and succeeded in increasing the output efficiency from 47% to 57%. We sell and manufacture this as emballed version water wheel, Waraweko. Here, we will introduce the case of Tsuru City, Yamanashi Prefecture as a past case. This project was in 2010, and I think this hydropower business was groundbreaking at the time. The type marked in the red is an example of open-type water turbine. I tried to calculate the profit for this case. Revenue was calculated using the initial cost, running cost, and power generation amount when all power was sold. Although detailed explanation is omitted, the construction cost, which is the initial cost, is high, and even if there is a subsidy, it is about 4.2%. And if there is no subsidy, the investment cannot be recovered in 20 years. So the key to early return on investment is how to reduce initial cost and running cost. Hydropower has high initial investment and is not profitable. It is a past story. We confirmed that it would be profitable if their scale was above certain level. At the United Nations Summit in September 2015, the SDGs for Sustainable Development was adopted. Composed of 17 goals and 169 targets, it pledged to leave no one behind. The 17 goals of SDGs, these 5 items are likely to be related to small hydropower. This is a questionnaire for all local governments conducted by the Cabinet Office of Japan in October 2017. According to this, 46% of local governments are aware of the SDGs, and we believe that local governments will actively work to reduce CO2 from now on. This is the first local government that has received SDGs award. The effort of such local governments are increased. Since small hydropower requires cooperation with the local community, it is a wonderful initiative that can effectively utilize unused sources and is a sustainable and economic cycle as a power source for local production for local consumption. This was a project of our company and Okayama Prefecture in 2018, but we were able to install it in half a year from the concept under the initiative of the local government. This project raised the issue of gas station depopulated area where there is no gas station nearby, and aimed to build a small hydropower plant and use small electric vehicle for local production, local consumption. The project was featured on news and raised a problem as a gas station alternative model. The current problem is the rapidly decreasing gas station. In Japan, there is a gas station depopulated area that is 60 kilometers round trip to the gas station, and it takes a day just to refill. Municipalities over 15 kilometers to nearest gas station in Japan go up to 302 municipalities. Also, if there is a power outage, you will need a car. This is a picture of line waiting for refueling event of the power outage, but this line is as long as 1 kilometer. If the project goes on, EV will be enough to power a house in the future. The other day, the Ministry of Agriculture, Forestry and Fisheries also visited this project and is attracting attention. Compared to light truck, it looks like this, and car sharing can be further increased profitability. In the future, it is conceivable that microcar will become smaller electric mobility. This graph shows the CO2 emission of EVs by the power generation method. In the future, if we use the projects introduced earlier and the electricity generated by renewable energy, CO2 emission will naturally be zero. In order to achieve carbon neutrality in 2050, it is important not only for our generation, but also for children who will bear the future to provide environmental education. Renewable energy is also effective as a backup power source in the event of disaster. In the future, the market will not be established only by the competition of electricity prices. Environmental value will be passed on to the electricity prices. This is an example of power outage caused by a reduction in investment in distribution equipment and an aging transmission line. In short, the depreciation period of transmission line is 36 years in Japan, but it is still used after that. This is a graph of power transmission line costs in Australia, but as you can see, the west of power transmission cost is increasing. It is the words of a civilization critic, Jeremy Rifkin. In other words, renewable energy is not purchased from overseas like oil. Japan spends more than 10 trillion yen on fossil fuels annually. The value of fossil fuel imports in 2010 will account for about 3.5% of GDP, which has increased tenfold in the last 10 years. Not only economic rationality, but also environmental value and idea of SDGs are important. Small electric vehicles are now capable of two-seater public roads, and some are four seats. In Japan, it is estimated that the number of electric micro-vehicles will increase to 8,000 by 2025. Renewable energy can also be used for electricity to deliver relief supplies by drone. We believe that such eco-station will replace gas station in the future, and the possibility of using electricity will expand to agriculture technology, drones, and the use of electricity in the event of disaster, where electricity consumption is currently increasing. We hope that you will take this opportunity to become interested in our products and initiatives. Thank you very much.